goes. So a matrix, a rectangular array of numbers. Ours will be majority numbers and or variables. Now you will see too, especially because I know some of you are taking AP Computer Science next year. Now, not my wheelhouse at all, let's just be honest about it, but they use arrays, matrices, a lot in computer science, but they call them an array versus a matrix. So there are some computer programming applications to this, again, not my wheelhouse, but some of you will be seeing that next year. Okay, rows, more vocab. Rows, horizontal, rows go across. So for instance, like in this matrix here, this would be row 1. Rows go across. So top one, row 1, bottom, row 2. Columns. What is happening?
Columns are the same thing.
Oh boy.
It's like we're twins or something.
Yeah.
Columns up and down. Okay. Now, we're also going to be looking at the size or the dimensions of the matrices, especially when we start doing some operations like adding, subtracting, multiplying, using our graphing calculator. So it's important you can give the dimensions or the size correctly. It's the number of rows first, and then the number of columns. And kind of how you'll see it, how it will appear on your calculator. So you'll put your number of rows in, whatever that is, and then this means by the number of columns. I'm just going to abbreviate. So if I was giving the dimensions of this matrix in the picture here, there are 2 rows, 3 columns. So it's a 2 by 3. And when we get to the calculator part, when you put those dimensions in, it's going to space it out 2 by 3, and you can start typing in the numbers when we get to that. Okay, we are going to be writing augmented matrices today. Super easy. We are taking a system of equations, and we're going to take out the variables and just work on the coefficients. So, if you can multiply and add quickly, this is going to be super easy for you. Okay? If you can't, you're probably going to hate it. So, x's, 2 and 1. So you can see that's your first column. Y's, -1 and 4. And then you equal 5 and 7. And a lot of times, different textbooks, of course, different things, you know, what you get used to. This is just me. For the equal sign, you'll see me when I write them. I always like to put a little dashed line in here, just to kind of separate off the numbers that they equal. Do you have to do that? No. Probably I just do it more so on anything that have it. Alex, what's happening back there? Okay, fair enough. Okay, so all we're going to do to practice right now before we get to our Gauss-Jordan elimination, our focus of the day, we're going to write this in an augmented matrix. So my coefficients on x are 1 and -1. Coefficients on y. I like the dashed line for the equal sign. That's just how I roll. And then 7 and 2. So when we start solving systems by Gauss-Jordan, this is going to be the very first thing I'm going to do, is write it as an augmented matrix. Easy enough. Now notice, you're missing some variables. We're going to have an extra column on here. You have x, y, and z. Anytime you're missing something, 0 holds the place. Keep it lined up. So we have 1x. The second equation, you have 0 x's, bottom 1x. So make sure you keep everything lined up. Y's, we've got 3. We've got -1, 0, z, we got 0, 4, -5. I like the dash line. Got it. So that's going to be the very first thing when we start solving systems. The purpose of today is I'm going to write them in augmented matrix style. Now, to solve these systems today, it's going to take us 4, generally, unless something weird happens, 4 matrices to do it. That's the first one, just writing out the problem. Okay, so we're going to use, of course, what we call elementary row operations to solve these today. Just think about when you did your elimination, your 3 equations, 3 variables, your eliminations, operations we did. Well, the order you stack the equations doesn't matter. So I can interchange 2 rows. I can just reorder it. You can multiply a row by anything but 0. Multiplying by 0 does nothing. So multiply it by 0, not anything but 0. And then, of course, we can add. Just like when you do elimination, we add those equations together. So we're basically doing kind of elimination, but in a matrix style. Get ready for it. So, just to practice, working our way up. First thing I'm going to show you, when it says to interchange the first and second rows. Okay, big deal. So I'm just flip-flopping these. That's all I'm going to do. So -1, 2, 0, 3 up top, 0, 1, 3, 4 in the middle. Bottom stays. Doesn't say anything about row 3. So you will see sometimes I might interchange 2 rows, and you'll see why in a minute when we get into it. Remember that you're just restacking the equations. Who cares the order you stack equations? It doesn't matter. Okay, here's where we get into some multiplying. Now, sometimes you'll see they write out these fancy row operations. That's this shenanigans here. I'm not always that formal and fancy. I'll show you both ways, of course. Multiply the second row of the matrix by -2. And then they want you to add it into the first row. So, what that means for us, clearly, they're not talking about the third row at all, so the bottom row just stays as it is. So I'm going to fill that guy in. Now, they want you to multiply the middle row by 2 and add it to the top row. So the top row is the one that is going to change. The middle row stays as is. And now I'm going to, of course, do that calculation. I'm going to times the middle by 2, add it to the top, or -2, sorry, -2. -2 times 1, -2, plus 2. -2 times 3, -6, plus -4. -2 times -3, 6 plus 6. -2 times 0, 0 plus -2. So these are the types of calculations we're going to be doing. We're going to be multiplying rows and adding them into other rows. So like I said, if you can multiply and add quick, piece of cake. Now, here we go. So we're going to solve these matrix equations using what's called Gauss-Jordan Elimination, named after 2 mathematicians with the last name Gauss and the other one Jordan. Got it? Okay, this is incredibly wordy. You will see too, especially when we get to your calculator functions, there is a row echelon form, we don't want it, and a reduced row echelon form. This is the one we're focused on, and you'll see why in a minute. Now, I'm going to give you the quick summary of all this here, okay? So, and I'm kind of a picture person. Over on the right-hand side, that's a matrix in reduced row echelon form. If, not saying it happens every time, it sure doesn't. If you have a whole row of zeros, has to be on the bottom. 0 equals 0 means what for an answer? IMS. We're going to have to deal with Z as A and all that again, too, when that happens. But anyway, we'll deal with that when we get to it, okay? Reduced row echelon form. You want diagonal ones, mine are in red, wish we had color copy machines, diagonal ones, and then the numbers below them, below and above are zeros. So ours is going to be a little bit more specific. This is just a general version. You will have a straight diagonal of ones, zeros above and below. The last column can be anything. I don't care what the last column is. Whatever. That's what we're after. Now, you know I like to get carried away, okay? Probably got a little carried away here. I can't help myself, you know? So, here's the thing. Can you multiply and add, in theory, any row at any time, at any point? Yes. But, work smarter, not harder. If you work in a specific order, you won't have to go back and change numbers, okay? This will be the most efficient way to work. So first thing I'm going to always do is I check for a 1 in this top left corner. That's where I start. If there's not a 1, what do I do? Well, maybe one of these other rows have a 1. I just flip-flop them. Who cares the equation, the order that you write them? Who cares? If it's a 5, I can divide everything by 5 and reduce it, okay? So that's where I start. Then I'm going to use that 1 to change the numbers underneath to zeros. So we're going to work a column at a time. Once I have that one set, that would be my first matrix, then I go to the next column. And I'm going to first make sure I have this diagonal 1. The diagonal. If I don't have a 1 there, same thing. Maybe I can swap it with another row. Maybe I could divide by whatever I need to divide by to get 1. Then I'm on the third column. I'm going to make sure I have the diagonal 1 in it first, and I'll use it to change the other numbers to the zeros. So my overall goal is I want this diagonal of 1s and the zeros above and below. That's what we're going to work on. And the nice thing is, if you think about this, let's say I just make up some numbers, 4, 5, 6. 1x equals 4. 1y equals 5. 1z equals 6. When you are in reduced row echelon form, it's a mouthful, diagonal 1s, zeros above and below, the final column are your answers for x, y, and z. That's what we're after. Okay, are we ready? Okay, first step, write out the augmented matrix. What's it using? Right. So just the coefficients, 1, 2, 3 for x, 3, 7, 10. Now kind of space it too. Remember I said in general it takes me about 4 matrices to get it done. Sometimes less if something weird happens. I like the dashed line for the equal. That's how I roll. So I kind of space it. Obviously I'm going to do the next one here next to it, and then I'll do like 3 and 4. Okay, so again, I'm going to go super slow on the first one because we've never done this before. I work on a column at a time. The first thing I look for is this 1. I've got it, I love it, I'm keeping it. If it wasn't a 1, if either the 2 or 3 were, I just flip-flop them, or I divide everything off. So the top row is perfect, I don't want to change it. So I'm just filling in the 1, 3, 4, 7. Give you a second to write. Now you use the diagonal 1 in each column, so I'm in column 1, to change the other numbers. So easy question for you. I'm going to do the 2, then I'll do the 3. Let's start with the 2. Easy question. What cancels out 2? -2. So I'm going to times this entire row by -2, and then I'm going to add it into the middle one. So I'm going to top red numbers all by -2, add them to the middle. So -2 times 1, -2 plus 2. I need longer arms. -2 times 3, -6 plus 7. -2 times 4, -8 plus 5. -2 times 7, -14 plus 10. Got it. So next up, I'm going to need 3 to be a 0. Easy question. What cancels 3? Okay, so what I do, just super easy, because I'm working always off the 1, I change that to a -3, and now I'm going to add it to the bottom. -3 times 1, -3 plus 3. -3 times 3, -9 plus 10. -3 times 4, -12 plus 4. -3 times 7, -21 plus 27. Got it. So I'm going to stop for a sec. Any questions on any of the blue or black numbers? Okay, column at a time. We're working on column 2 now. Okay, so we've got the original problem. I'm just going to scroll this up a little bit so I'm not at the way bottom here. Okay, now first column is perfect. 1, 0, 0. I'm working on this one. Now, first thing I look for in column 2, remember, diagonal 1s. You've got the diagonal 1. That blue 1 is perfect. I love it. I'm going to use it to change the other numbers. So my blue numbers are perfect. So I'm going to fill in the middle row. I'm going to keep my 0, 1, my -3, and my -4. Now, we have to change the 3 above it to a 0 and the black one below to a 0. It makes no difference which one you do first. We have to do them both. I picked up green, so I'm going to do the green one. So I'm going to get rid of 3. Easy question. What cancels 3? -3. So we're timesing these blue numbers by -3 and adding them into the top row. -3 times 0, 0, plus 1. -3 times 1, -3, plus 3. That's what we wanted. That's what I was trying to do. -3 times -3, 9, plus 4. Negative 3 times negative 4, 12. 12 plus 7. My sloppy writing. Okay, black 1. Okay, easy question. What cancels 1? Negative 1. So now I just change this to a negative 1. I'm going to multiply them by, but add to the bottom row. Really, you're subtracting. Negative 1 times 0, 0 plus 0. Negative 1 times 1, negative 1 plus 1. That's what I was after. Negative 1 times negative 3 is 3. 3 plus negative 8. Negative 1 times negative 4, 4. 4 plus 6. I can tell you right now z equals negative 2.
What?
How'd I get it? You can get it. Remember those three equations, x, y, z. Negative 5 and the 10. If you divide those by negative 5, you have 1 and negative 2. Now, which I'm going to do, but I'm not going to rewrite this whole stupid matrix just to divide these by negative 5. If I was doing this legit and I had pencil paper, I'd just erase them and rewrite the numbers in. I'm going to cross them off and write them underneath. So if I divide by negative 5, 0, 0, 1, negative 2. So my bottom row, 0x, who cares, 0y, don't care, 1z equals negative 2. So I'm going to table that. I don't want to lose it. So 2 columns perfect, last column to go. So we're working on this one. Now, diagonal ones. I crush getting diagonal ones. We're going to keep that. We like our bottom row. We know z is negative 2. Final matrix, I'm going to keep the negative 2, keep the black numbers. I like my dashed line. You don't have to do the dashed line. Bless you. So we need to change the negative 3 and the 13. I don't care what we do. We got to do them both. I picked up blue and do a negative 3. So to get rid of negative 3, I need 3. So I'm timesing the black numbers that we love by 3, and I'm going to add it to the middle. 3 times 0, 0 plus 0. 3 times 0, 0 plus 1. Shocker. 3 times 1, 3 plus negative 3. 3 times negative 2, negative 6. Negative 6 plus negative 4. And you now know that y is negative 10. 0x, 1y, 0z, y equals negative 10. Okay, final number to change, 13. Okay, 13, I'm going to change the 3 to a negative 13. So now I'm going to times the black numbers by negative 13 and add them to the top. Negative 13 times 0, 0 plus 1. Negative 13 times 0, 0 plus 0. Negative 13 times 1, negative 13 plus 13. Here's where it really counts. What's negative 13 times negative 2? 26. 26 plus 19. X. You don't need a calculator for that.
Are you kidding?
Come on. X is 45.
This is awful.
I love it. Okay, now you can leave your answers just like that. You know I don't care. Or you can write the order triple if you would like. 45, negative 10, negative 2. Yes. That is. Okay, let's get real here, people. Real talk, real talk, real talk. Would I ever necessarily solve 3 equations for variables like this or do it like we did the other day with elimination? Probably just do it with elimination, okay? But when you get into higher level mathematics, you have bigger systems of equations. I can multiply and add pretty quick. If I have 5 equations, 5 variables, I'm going to crank through this because I can multiply and add quickly. All right, let's do another. Okay. Another. 4 matrices. Set it up. Augmented matrix first. Careful, you don't have y in that top one.
Pretty, I'm gonna get this one.
You want to try it on your own?
Yep. Okay, the number was cut off.
Oh, did the hole punch get it?
Yeah.
Okay, good.
Sorry.
I didn't look up there first.
take what I can get, Owen. At least I hole punched, at least does. Are we ready? Yeah, check the numbers. It sounds like the hole punch chops them there. Okay, column at a time. I gave you that top left one. Again, and we'll see probably more on Monday. If it's not a 1, we can interchange the rows or divide something off if we have to. But pretty nice on day 1 as we start our Gauss-Jordan elimination. All right, let's get rid of 3. We got to do the 3 and the 2. It doesn't matter which you do first. We got to do them both. I'm going to get rid of 3. I need a negative 3. So I'm going to do negative 3 times the top row, add to the middle. And like I said, is this the only order process you can work in? No, it's not. You can do whatever to get the diagonal ones. But if you do something different, you might end up losing a 0 and having to go back to change it. I'm trying to give you efficiency here. Negative 3 times 1, negative 3 times 0, 0 plus 1. Negative 3 times negative 3, 9, minus 2. Negative 3 times negative 2, 6, plus 5. All right, bottom row, we got to get rid of 2. I'm going to change this green negative 3 to a negative 2. And you're going to take a sec, if you haven't, and get me this bottom row. A little mental math. You should have 0, 2, then what? 7, last one, 8. 0, 2, 7, 8. Anybody need me to actually go through and calculate each of those? Okay, half done, kids, half done. Okay, column at a time. I'm working on the middle column here, the second column. You've got the green diagonal one. Again, if we don't, next to that Monday, we can interchange, we can divide. But we've got it, so my green numbers are perfect. I'm going to roll with them. 0, 1, 7, 11. Okay, hey, we're really winning this column. What's above my green one? 0 already. Yes, I'm filling it in. It's like I just won the lottery. Okay, let's get rid of the 2 with the negative 2. Take a second. Okay, bottom blue numbers. You've got 0, what? 0, now what? I heard it, negative 7. Final corner is negative. Z is 2. Divide those by negative 7, Z is 2. Now again, if I'm doing it paper pencil, I just erase them off and write a 1 and a 2. I don't want to make a mess up here, so I'm going to cross off.
So I did this wrong.
That's how I roll. Again, if I'm doing it paper pencil, just erase them and do it. Okay. Final matrix, final column. Now, we're working off the diagonal ones. You've got your blue diagonal 1. The blue row is perfect. Z is 2. We don't want to change the blue row. We love the blue row. Well, you might not love it. We like it. We love it. Oh, Lord, help me. Okay. You have to do the 7 and the negative 3. It does not matter which you do first. I picked up green, so I guess I'm doing 7. What gets rid of 7? So we're going to times the blue numbers by negative 7 and add it to the middle row. So 0, 1, now what? 0, negative 7 times 1, negative 7 plus 7, 0. Here's where it really counts. What's this? Negative 3. Negative 14 plus 11. Why? We now know why.
Yeah.
Okay, final calculations. We need to get rid of the negative 3, so 3. So I'm changing this 7 to a 3 and arrowing up here. 0, 0 plus 1. 3 times 0, 0 plus 0. 3 times 1, 3 plus negative 3. Here's where it really counts. 3 times 2 minus 2. What do you got? 4. X is 4. I love it. Hey!
It's not on
Ready for the final one of the day?
It's only gonna be like 2 of these in there tonight.
Yeah, these take forever.
Well, they do. That's why part 1, part 2. Woo! Okay, here we go. All right, 1, 1, 2, 1, okay, 0, 0, 0 for Y there. Catch it.
Our equations are.
Did it hole punch this one too?
Yeah.
That's what I get when I hole punch for you
Oh,
kids.
You're the only one that is
Bro, Alex, shut up.
Oh, that's great.
I'm glad I'm recording this for the absent kids. Shut up. All right. Sorry for those at home watching this.
On the videos next week, can you guys talk to me?
Yeah,
All right. So top left corner is a 1. As always, I mean, today we're starting easy. They're usually 1s. But if not, thinking about Monday, we can always interchange rows if there's a 1 somewhere else, or you can divide something off. But column at a time. That's looking great. I'm going to keep that top left 1. We love it. Okay. I hear you guys trying it. Do you want to kind of try it and see what happens?
Yep.
Yeah.
Elliot, question?
In the second column, shouldn't there be a -2?
Oh, yeah. Thank you, Elliot. Good catch. I don't know why I have a 0 there. This is why I try not to erase out of this thing. Erases a bunch. Okay, let's get our middle row. So to get rid of 1, you need -1. -1 times 1, -1 plus that. -1 times 1, -1 plus 0. I'm going to have -1 times -5, 5, minus 2. -1 times 3, -3, plus 1. We're ready for the bottom row. Let's get rid of 2. I'm going to change this. I'm just going to write it next to it. I'm going to cross it off. -2 times 1, -2 plus 2.
Would it not be? Yeah, that's just
-2 times 1, -2 plus that.
What's wrong?
-2 times -5, 10, minus 1.
I'm wrong.
-2 times 3, -6, plus 0.
Hey. Miss Brian.
What? What's happening?
I think your math is wrong.
Did I miss add somewhere?
On the
green 3.
The green 3. The green 3. So, because we did -1, right?
That's what I got.
This is no
-1 times -5 would be 5. 5 minus 2, 3.
Well, how did we all get
Right?
change?
I got it.
Wait, did you change that to a -2? Oh yeah.
What?
Did you
-2.
change that to a -2 though? Like that had to be a 0 or something.
I think, yeah, Elliot caught it. I miswrote it. That
what?
first, yeah. But no, -2.
Oh,
I got it right, Mr. Fire.
Thank you, Alex. Okay.
I know what I did. I know what I
Yeah,
did.
Cal.
Pro tip.
I got a 0.
Anybody have a guess on an
Where did I
answer?
get a 0?
On what?
It's no
Anybody have a
solution.
guess on an answer?
It's no solution. It's all. It's either no
All right, let's
solution.
keep going.
It's either
Let's
no
keep going.
solutions or all solutions.
Just
It's
ask
one
it.
of the two. It's not a direct answer though, because the next one doesn't work.
All right, so
Because it won't work.
we are working a course column at a time. Now, I'm close here. I'm close. We need this negative green 1 to be a 1, because diagonal 1's. Super easy. To make it a 1, I'm just going to change all the what? Signs. Am I going to rewrite it and make a big deal? No, I'm just going to change it and do it, right? So I'm going to fill it in here as 0, 1, -3, and then, of course, 2. And I'm just going to go ahead so it's in front of me. I'm going to change them here also. Just change it. Make your life easy. Okay, let's get rid of the red 1 first. So to get rid of 1, we need -1. -1 times 0, 0 plus that. -1 times 1, -1 plus 1. -1 times -3, 3 minus 5.
oh my goodness.
-1 times 2, -2 plus 3.
Okay, how do I do this one?
Remember, we changed the signs on the green number, so you're using the switch sign.
Wait, so how does the
values.
1 stay the same?
-1 times 0 is 0. plus 1.
Oh, I'm doing this wrong the whole time.
Oh, Lord. Oh, Lord. Okay, let's get rid of negative 3. We need a... So I'm going to change this to 3. I'm scared.
I hate it.
Okay, 3 times 0, 0 plus 0. Imagine how bad this would have been if we had a snow day today and you had to learn this on video.
Yeah, I probably would have given up 6
3 times 1, 3. 3 times negative 3.
I still believe it's no.
3 times 2, 6.
A while ago, Courtney.
What does that mean? That row is 0.
All solutions. This is
All solutions, infinitely many. 0x, 0y, 0z.
I said, oh, you said no.
okay, Alex.
Yep, we're still going.
Bro.
Woo, woo.
Oh, we did A now.
Okay, but hold on, I'm going to back up the truck a second. Remember, I asked you on this matrix here
Hit by a truck.
if anybody had an answer. I could have told you from this matrix it was IMS. Yes, I still had to keep going to do the work, but I recognized it right here. What's significant about the green and the blue numbers?
They're the same thing.
They're just multiples of each other, correct? 2 4s, 3 6, 4 8s, it's all a half. They're just multiples of each other. So right away it's like, oh, multiple of 3. Same equation, really, it's IMS is what I'm going to end up with. Now, we have to do the Z is A thing yet.
That's how I feel.
Now, you might, think I'm just trying to sell you stuff here, but I do think the Z is A is easier on this. Here's why.
No, I finished that.
So clearly 0 equals 0. I'm done with the blue numbers. I'm on the green. If I said, hey, write the green row equation style, I'm not putting 0x, that's dumb. I'm going to have 1y minus 3z equals 2. Well, I can pretty much almost do that in my head. If you replace this with a and solve for y, you're going to have 3a plus 2. Throw it in there.
Oh, I see.
And you can do the same for x. Recover the top red numbers equation style, and you can mental math it and solve for it. So I'm going to have 1x, I'm not writing 0y, minus 2z equals 1. So if I put an a in there, I add it over, what is x? 2a plus 1.
Oh my god.
Okay? Last question before I quit torturing you. What if this was 0, 0, 0, 7?
No solutions.
No solution. 0 doesn't equal 7. So that's how you can tell you have the no solution system. Do you love it?
No.
We have these Friday.
All
5
right.
of these to do on the homework.
Let me grab your, come on. Let me grab your homework for you.
5. Okay.